And they go down to Columbia. They travel down there, 2-hour drive. And they get down there and they get a hotel room. Now, this joke / story was done a long time ago. And it can be done with any numbers, but I'm not going to confuse anybody. I'm going to use the numbers that were used back in 1920 when it was made up. So you got dang old South Carolina, dang old state, looks like a triangle, dang old Clemson, dang old Columbia. So they go down to Columbia, and there's 3 guys. 3 guys, they get in the car and they go down to Columbia. And they go down there and they say, well, we need a hotel room. So before Columbia got all big and high and mighty, there used to be a lizard thicket right on the outside of Columbia. And right across from the lizard thicket was the Econo Lodge. All right, y'all remember that? Some of y'all remember that? Okay. Well, they stop at the Econo Lodge and it's $30 a night. Per night. And they say, well, we're right outside. We're at this exit. It takes about 15 minutes to go into Columbia to get to the stadium. So that's okay, 15, 20 minutes. If we leave early enough, we'll stay here. It's real cheap. And we'll kick the rats out. But $30 a night is pretty cheap. That comes out to how much? I mean, there's 3 guys, right? $10 a piece. And they give the man $30 and they go up to the room. The Econo Lodge back then was just 2 stories, okay? And they stay there, they get in there, and it's about an hour passes. And the guy that owns the Econo Lodge, he's an old man, he's a grandpa. He says, I charged them too much. I gave them a room without blah, blah, blah. I need to give them $5 back. So he takes a $5 bill, and he gives it to his grandson, and he says, go give this $5 bill back to those guys that just came in here. And he goes about halfway upstairs, and he says, how am I going to give a $5 bill to 3 guys? So he runs back downstairs and tells his grandfather, he says, Grandfather, I need 5 ones. And he says, okay, 5 ones. And little grandson goes upstairs and he says, how am I going to give 5 ones to 3 guys? And he said, I'm not going to ask my grandpa again because he's going to get mad. I don't know what to do, so I'll just take 2, put it in my pocket. And I'll give each one of them $1 back. So they pay how much for the room? Huh? $9 a piece, right? Yeah. 9 times 3 is, wait a minute, plus the $2 in his pocket. Where's the extra dollar? Where's the $1? He put 2 in his pocket. He gave each one of them $1. It's $9 a piece. 9 times 3 is 27 plus the 2. What happened? Where'd the $1 go? Anybody ever heard this before?
I don't know, but I'm really mindful.
It's your parents' fault. First time I heard this story, I was about 17 years old, 16 years old, and we were surveying for this guy. He had 1 tooth in his head. 1 tooth. I mean, when he grinned, all you saw was pink. I mean, it was just... Anyway, he told me this story. He said, it's the black hole of mathematics. He was smart enough to tell the story, but he didn't know how to explain the answer. There is an answer. He didn't put $3 in his pocket. He didn't drop it. He didn't get a Coca-Cola. He didn't do anything like that. There's all the math right there. Where's the $1? Wait. Nobody's going to answer. Nobody knows.
I know.
Order of operations. What are you talking about? What did I do first? I subtracted. And then I what? Multiplied. Can't do that. You got to multiply first, then subtract. So you do 10 times 3, and then you subtract 5. 10 times 3, and subtract 5. What did I do? I did 10. Everything went right. 10 minus 1 multiplied by 3. And then I added 5, or whatever the case may be. Alright? The whole thing is, I set up the whole problem subtracting first, then multiplying. And you're not supposed to do that. Well, how do you know what's supposed to do? Well, most of the time people will start yelling out, please excuse my drink salad. Well, 90% of the time, that's true. Somebody's going, what about the other 10% of the time? I was always told, please excuse my drink salad. Well, when you have a mathematical sentence made up of these two guys, or these two guys, you have to do something different. Now, why did I put addition and subtraction together, and why did I put multiplication and division together? Why did I do that? Why couldn't I put addition and multiplication together? Why did I put these two together, and why did I put these two together? They work together or they undo each other, right? So, you could say that these two fuss and fight all the time, right? And these two fuss and fight all the time because they undo each other. Right? What blood kin fusses and fights all the time? Brother and sister. So if you have a sentence with brother and sister, how do you do it? What's the order of operations with brother and sister? Which way do we read? Left to right. Left to right. If you have a mathematical sentence and you have 3 minus 4 added to 17, then you have to go left to right. If you use please excuse my dear Aunt Sally, you might get a different answer, and it's wrong. Okay? So, as an example, now sometimes it'll come out right, but sometimes it won't. So, you gamble on sometimes it comes out right, or you make sure you know what you're doing. You make sure you know what you're doing. So, 3 minus 4 plus 16. 3 minus 4 is negative 1. Negative 1 plus 16 is 15. Now, if you did negative 4 plus 16, what would you get? You get 12. 3 minus 12 is? You got two different answers. Which one's right? 15 is correct. Because you go left to what? Left to right. I guarantee you somebody in here is going, I've never heard that before. Well, it's true. You were just told, please excuse my dear Aunt Sally, or you interpreted it as a one shot, one kill. In other words, it takes care of everything. It doesn't. Or if you're from somewhere else that doesn't use please excuse my dear Aunt, it's PEMDAS. I had a student. I don't understand what you're saying. Please excuse my dear Aunt Sally, Mr. McClure. We use PEMDAS. What do you want to do to those type of people? You just not living. Take a bath. to them with a spike on the end of it.
So
We didn't use that. We used PEMDAS. All right. So when do you use please excuse me, dear Aunt Sally? Well, let's take this blue marker. Whenever you got a crisscross of these two, these brother and sisters are kin to these brother and sisters. What do they call it?
Cousins.
Cousins. And cousins go to Aunt Sally's house. So if you have a sentence and you've got 2 times 3 minus 6, you do, please excuse my dear Aunt Sally. All right, let's do 1, 2 times 4 minus 6. Well, I don't want to do it that way. I want to do 4 minus 6. 4 minus 6 is negative 2. Negative 2 times 2 is negative 4. And you're wrong. 2 times 4 is 8 minus 6 is 2. What is PEMDAS? Please excuse my dear Aunt Sally. I really do have students like that. I really do.
I wish I was that student.
Huh?
I wish I was that student.
No.
Just to get on your nerves.
Yeah, just to aggravate me? Okay. I don't know what you're talking about, Mr. McClure. We use PEMDAS. That was the lady's exact words. And most of these people that I tell you about, they ain't from around here, as the old saying goes. What does that mean, people from around here? When people ain't from around here, what does that mean?
They don't understand.
They from which direction?
North.
Yep. Nothing against northern people. Most of y'all are nice. It's the damn Yankees, the ones that... What's the difference between a Yankee and a damn Yankee?
Damn Yankee stay home.
Damn Yankee needs to go back up north.
To his pride.
All right, let's try nerd. Let's try this one. 3. Oops, we'll change it to black. Because it's not, please excuse my dear Aunt Sally. Oops. Black. 3 divided by 2 times 6. Now, no calculators, because we're not using calculators, because I haven't told you to get them out. So that means fractions. Well, no, Hubert. 2 times 6 is 12, and 3 divided by 12 is 1/4.
3 divided by 2.
No, that's not right. Huh?
So it'd be
You got to do 3 divided by 2 first, and 3 divided by 2 is 3 what? 3 halves. Multiplied by 6 over 1. Now what? Well, the 2 will cancel here, and cancel with this what?
3.
And what's 3 times 3? If you did it by please excuse my dear Aunt Sally, what comes first? So that'd be 2 times 6 is 3 divided by, what is 2 times 6? 12? And that's 3/12. And 3/12 goes down to what? Is 1/4 equal to 9? Then somebody's wrong. Please excuse my dear Aunt Sally is wrong. Because when you have brother and sister, you go what? Left to right. And that's just a kind of a refresher over the order of operations. Now, a lot of you may say, Hubert, I have never seen that before in my life. And I would say, no, you're probably right. You know why you've never seen this before? Because that's the way I learned it. I came up with the brother and sister and the crisscross and the cousins. So if you did see this before, it'd have to be from one of my other students, one of my former students. Okay? Now, did I make up the rule? No. The rule left to right comes from, they just say it, when you're taught the order of operations. They say, okay, if you have a mathematical sentence, you go from left to right. That's why I put in the brother and sister, because it kind of helps you remember the addition and subtraction and addition, they undo each other. Now, I'm not going to spend a lot of time on these, but I will show you two words that you need to know for your homework and your test. The two words in your instructions are determine and evaluate. Now, these two words mean the exact same thing as far as what you're going to do in math. How many of you have heard the term plug and chug? All right. If you had an old mathematics teacher or your parents that had an old mathematics teacher, that's where that term comes from. Some people say plug and chug, when it comes to science, when it comes to the formulas, especially in physics. Because your physics, that's all you're doing is plugging and chugging. That's what both of these words mean. When you see these words in directions in your homework or your test, that basically means you're going to plug and chug. But what's the difference between the two? Well, the difference between the two is with determine, you're going to get two solutions. I'll give you an example. Determine if 5 equals 2x plus 1 is a solution with x being equal to 1. Or 3, sorry. 2. Alright? Determine if 2 makes this. If 2 is a solution of this equation. So what would you do if they give you x is equal to 2? What would you do with that 2?
Plug it in.
Plug and chug. And when you do that, and when I tell students, whenever you plug in something, use parentheses. And you take that 2 and you plug it in right here. And what do you get? That's called an identity. Okay? Write this down because I'm going to go ahead and cover this. Later in the chapter, you're going to get it again. But let's go ahead and cover this. When you there's 3 types of solutions you're going to get in algebra. And I'm going to go over to the next screen. You can go over to the side of your notes or wherever. 3 types of solutions in algebra. One, the first type solution, and usually anywhere from 80 to 90%, this is what you're going to get. And that is a true solution. X is equal to 5. W is equal to 16. Y is equal to 3 halves. In other words, you did the algebra and you came out with y or x or whatever you're solving for is equal to a number. And 90% of the time, that's the type of algebra you're going to be doing. When the directions say solve. If the directions say solve, and you come out with a true statement, like we just did, 8 is equal to 8. 5 is equal to 5. 1/2 is equal to 1/2. In other words, your variables cancel out, and the only thing you're left with is 2 numbers, one on each side of the equal sign. And if that happens, you've got a true statement, which is called an identity. And when you have an identity, the solution is all real numbers. And we'll get to that when we get later on in the section and the chapter. We'll get to that. We'll get to this one. So on that determine if blah, blah, blah is a solution of blah, blah, blah. If you do the plugging and chugging and you get 5 is equal to 5, then the answer is a solution. That is a solution. In other words, 2 is a solution to that equation. But what if you don't get it? Well, if you don't get it, it's called a contradiction. If you don't get it, it's called a contradiction. And a contradiction basically is an untrue statement. I should have put untrue statement. I'm sorry. Flip it around. Let's just flip it around because that's not right. Untrue statement. Let's just take this and that's not going to do it. So I'll just erase the whole thing. An untrue statement probably telling us that we got classes canceled today because of snowing. Contradiction.
I should check that.
No, it just made me mad. 4 is equal to 107. Negative 3 is equal to 4. X is equal to W. Negative 5 is equal to 1/2. These are all untrue statements. And when you get an untrue statement, it's called a contradiction, and the answer is no solution. In other words, you can't get a solution to the problem. So those are your 3 types of answers. Now, most of the time on this test, 90% of your test probably is going to be this. All right? But you may get a couple that comes out to be totally wampus, out of wampus. Y'all know what wampus means, don't you? Out of wampus,
Not correct.
out of balance. Doesn't jihad? You know where jihad comes from?
Oh, there's some redneck person.
No, a farming term. Anybody know where jihad comes from?
Is it a term from horse, I'm guessing?
You getting there? Not a horse, but a
Donkey.
not donkey.
Jackass.
Mixed between a donkey and a horse.
Mule.
Mule.
I just said mule.
What does a mule do 90% of the time back in farming days?
Mule?
What?
Do things like around.
It's your parents' fault.
Yeah.
What does a mule do?
Wow.
Plow.
Oh, wow.
Well, how do you tell a mule which way to go when he gets off the center of the road? G means left, ha means right. Well, a mule don't know. Mule's smarter than a horse is. And you tell a horse when you want it to get going. And you tell, what do you tell him when you want him to stop? Whoa.
When I was learning,
How does he know that? Is he smart enough to know that? And a mule's smarter than a horse is. They're stubborn. I didn't say they weren't stubborn. I said they're smart.
I was learning to ride a horse, and I was like learning how to make it go faster.
Mm-hmm.
And I didn't really like. I
Kick
was
it.
young, so like my foot was tapping against his neck, and it was going faster and faster, and I didn't know how to stop it. Then the guy like from behind just screamed at it, and it slammed in my head.
My dad bought me a pony.
Yeah.
I never did care for horses. Are beautiful. I love horses and they're beautiful, but I don't want one. I don't want one. They're too unpredictable. Anyway, I got on this pony. And I decided I was going to open her up on pasture beside my poor road. Just open her up. And she opened up. I was going. Just going. Until we came to a power line. And guess what that dang pony did? I don't know how she stopped that quick, but when she stopped, I went. And I never did get back on one. I don't care if it's nothing about it. But anyway, Jihad doesn't jihad. It's out of balance. In other words, it doesn't work. These don't work. And if you don't believe me on jihad, Google it. G-E-E, ha, H-A-W, jihad. Google it.
I'll let you Google.
I'll take up time during class, and somebody will complain to my boss, and then I'll send Dr. Body in here, and then y'all will hate life. All right. So let's go back. So this is a true statement. So yes, 2 is a solution of this equation because you plugged it in and you got an identity. Evaluate. Evaluate is when you're given this. 2x plus 4 is equal to y, and x is equal to 3.
Soften one.
Basically, what do we do with that 3? Plug it in. 3 will go into, it'll be 2 times 3 plus 4 is equal to y. And what is 6 plus 4?
10.
So y is equal to 10. And we just got one of those solutions that you'll get 90% of the time. Now that's pretty much going to be what you're going to be doing in the first section of 5.1. This is what you're going to be doing for homework. Is this a solution of this equation, or evaluate? Here's another evaluation. (2x plus 3y is equal to 16. X is equal to 4. Y is equal to 3. And then they'll ask you, is it a solution? So I'm sorry, determine. That's determine. Sorry. And they don't even have to say determine if so-and-so. You're supposed to know that if they give you an equation and it has x and y in it, and then they give you x is equal to blah blah and y is equal to blah blah, you're supposed to know that you're going to do what? Plug each other. So 2 times 4 is equal to 3 times 3. I'm sorry, plus. And 2 times 4 is 8. Plus 9. Is that a true statement? So what is this? Contradiction. It is not a solution. So this is not a solution of this. And that's pretty much going to be all your 5.1 homework, or whatever chapter we're in. So 6.1 homework. Plugging each other. I'm not going to spend a lot of time on it because you're talking about 10% of your Unit 2 test, which means probably 1 or 2 questions. One of them will be an evaluation, one of them will be a what? Determine. So I'm not going to spend a lot of time on this. I do want to spend a lot of time on algebra, because you're talking about 80% of your Unit 2 test is going to be the next couple of sessions or the next couple of times we meet. It's going to be what it's going to be about. So if you want to go ahead and work on the algebra section, that's fine. I don't know what section it is. It's probably 6.2 or 6.3. Somebody tell me what 6.2 talks about. And that's where it starts. 6.3, what is it? Formulas, no. Don't worry about formulas. That's only 10% of the test too. What's the next one? 20%, but we're going to do that last. What's the next one?
Your percents are adding up.
What? Variation is 10%. It's very small. Next one. There you go. And what's the next one after that? Okay, I break this chapter up into two. I break this unit into two tests. The first one is going to be 80% from 6.2. And what was linear inequalities? 6.6. Okay? 80% of your test is going to come from those two sections. So you better make sure you know how to do those homework problems. And I will give you the worst problems I can make up. Okay? Because one thing I want you to be able to do when you get out of this class, when you see a fraction, you just say to yourself, okay, I need to do this, this, or this. When you leave my classroom, I don't want you being afraid of, and I showed you how to add fractions. You should be able to add and divide, and you should be able to add and subtract fractions with no problem now. So now we're going to do fractions in algebraic equations, which depends on the common denominator. Again, you're starting to see why people don't understand how to do algebra. Why don't people understand how to do algebra? They don't understand fractions because either they didn't listen or the teacher didn't teach them. Just do it on the calculator. Now, there's 4 operations. X plus 4 is equal to 6. X minus 2 is equal to 12. 2x is equal to 14. And x divided by 3 is equal to 12. Now, before everybody gets all happy and say, oh yeah, I know how to do that, this ain't going to be on the test. Okay? This is what everybody knows how to do. But you got to start somewhere, so this is where I start. There's 2 things that you need to remember about algebra. 1, your main goal is to get the variable, what? By itself. By itself. I don't know where that came from, but that sounds kind of risque. It's left. I don't look good either, but it's self. What's the second rule? Well, the way that you get the variable by itself is you use the theory of equality, which basically says if you do it to one side, you got to do it to the other. So the theory of equality is number 2. What you do to one side, you have to do on the other. And most of y'all know those 2 things from pre-algebra. Whether you took it 5,000 years ago, as some of y'all say, or whether you took it last semester in 032 or whatever it's called now. So everybody knows that if you want to get rid of a positive 4, you what? And by the theory